So this is the membrane cell that you'll see the link to in the live worksheet. If you are able to access it, it is a bit of a tricky installation to get the flash player to work. So if you don't worry, you can just look at this. So this membrane cell is called that because it has this selective permeable membrane in the middle there. Now what happens is you're pumping in concentrated brine, which is salt water, on the one side of the membrane, and that salt water is obviously Na and Cl ions. And what happens is you'll see at the bottom here is the reaction for Cl. The Cl ions get attracted to this positively charged electrode that they put in here, because this is obviously an electrolytic cell, so it's got a positive electrode and a negative electrode. And when that Cl goes to the positive electrode, it needs to become neutral, and it will do that by giving off 2 electrons, because remember it's diatomic. And when it gives off those 2 electrons, the Cl ions, which was part of the salt water, becomes chlorine, which is obviously a gas, and you'll see it basically just bubbles off here, the chlorine gas. On the other side of the membrane cell, you have water being pumped in on that side of the cell. Now the water is going to go to the negatively charged electrode, and it's going to do this. Now this reaction looks very strange, but it's actually on your half reaction table. You'll see the water will then basically reduce, gain 2 electrons, and become hydrogen gas, which you'll see bubble off here, and it will become hydroxide ions. So the purpose of the chloroalkali industry, or this membrane cell, is to make 3 things: chlorine gas, hydrogen gas, and then sodium hydroxide. So where does the sodium hydroxide come from? Well, when that water reduces, it forms hydroxide ions, which are then in solution here. Now, how does the sodium go from this side, where nothing happened to it, to this side, where it actually can join with the hydroxide and become sodium hydroxide? What happens is interesting. The chlorine will now go here and oxidize. The sodium will be left behind. And now look at what happens to the sodium. It actually goes through the selective permeable membrane called a cationic membrane, because it only allows cations through. And it then joins up, because remember sodium is positively charged, hydroxide is negatively charged, joins up with the hydroxide ions, if you follow it here, and then it creates sodium hydroxide. Okay, and sodium hydroxide is used in soaps and detergents and other things that you'll see on the live worksheet, and that is then one of the products that you want to form. So then you have your 3 products. You have your chlorine gas, you've got your hydrogen gas, and you've got your sodium hydroxide. Then on the live worksheet, you need to compare this to the diaphragm cell and mercury cell, and you'll see there's quite a few reasons. The number one being like the safety. The diaphragm cell uses asbestos as the membrane, and the mercury cell obviously uses mercury, which is toxic, and that's why this is the cell that is preferred now.